Okay, good morning. Welcome to the second session of the Scientific Communications class final presentation.
Good morning.
The first presenter for today's session is Johnson Fernando Yangjo. Okay, if Johnson's is not arrived in the meeting room, we're going to move on to the second presenter, which is Fajar Riwan Sidik. Is Fajar in the classroom?
Yes, sure.
Okay.
Can you hear my voice?
Yes.
Can you see my PPT?
Yes.
Yes, sure.
Okay, whenever you're ready, you may start your presentation.
5 minutes. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everybody. My name is Fajar Riwan Sidik. My student number is 102-17102. Today, I would like to presentation my paper to tell about relay wave velocity inversion in the application of surface wave method. Maybe if you have some question, feel free to ask me. But first of all, I want to tell you why it's important for us to know about it. Okay, we can look at figure 1, who giving us an information about impact of earthquake, and figure 2 giving us an information about oil mining. So why? As we know that the earthquake is something can control by by human. In effect, to predict when earthquake will be occur and how big it will be, human can know it. Until now, human have not be able to do it. To know when human be able it be happen and how big. And we also know that the width below the surface the earth is very abundant, like the gold, oil, water, gas, and so on. However, due to the limitation of human vision, we cannot determine the exact location to get a material we want of Earth's surface area. So from these two incidents, we can take one thing, that human can make some prediction to minimize their impact and disadvantages. So how we can do prediction? To predict it, we can use MISW, multi-channel analysis surface web, by using relay inversion. So in this paper, I have some purpose. One, to know result dispersion curve from relay wave by using MATLAB and plotting of the PS velocity of depth. And the outline of this paper, I want to tell you one about a basic theory, and secondly about experiment method, thirdly about result, and fourthly about a conclusion. And we are going to this first part. And what the MISW? MISW or multi-channel analysis of surface web is a field testing method that doesn't diminish the improvement to obtain the value of a practical cell wave velocity Vs and thickness of soil structure. This method make use of the dispersed property of valley waves in the layer soil system. The penetration properties of valley waves in the medium are influenced by wavelength and frequency. And next, and how about relay waves and relay inversion? Relay waves are a type surface wave that occur an result of constructive interference between a comprehensive wave and shear waves. The motion of a particle in the relay waves of relay waves are of space medium. Another characteristic of relay waves is that their amplitude decreases or decreasing exponentially with the deep below the surface. In generally, this wave has a low frequency with a spectrum that is not sharp. Relay waves have a unique characteristic that is wave propagation that cross the boundary of the our material layer will experience dispersion. Relay wave inversion is performed to model subsurface structure. The solution to the problem for the relay wave velocity or PR dispersion curve is power modeling by knowing the dispersion density. By knowing the parameters such as density, rho, wave velocity, Vp, and wave velocity or Vs. After knowing a VR, then inversion modeling is done by determining of the model physical parameter or the measurement called the identification of model parameter by inverting the observed variable to get a good uh, approximation on the model parameter that depend on the selection of the response. Uh, this is a mathematical method of this Rayleigh waves. It is simple equation, but in the back of this, it's hard to get this equation. The equation is Vs uh, where the Vs is equal to root of shear coefficient divided by rho and is equal to root of GO 1 plus mz divided by rho equal to root Vs 0 root by 1 plus mz, where Vs is wave velocity, rho is Gibson half space mean density, and z deep and g is shear coefficient. This is in this experiment, I'm using MATLAB to get uh, some model of this paper. We can use in this. We can look by. We can look the in this figure that first of all we must input two data. One data about H, Vs, and Vp. In another file, we can include by in this in on this on this. Can you see my cursor? Okay. In this by left click and then you can input the data, and the data is about H, Vs, and Vp. And this section we can see the graphic of the VR of frequency, and after that we can get a result. Uh, we can get a result. Uh, we can get a result. We can get a result about the graphic of the phase velocity of frequency. and phase velocity of frequency. In this graphic, we know that this is a dispersion curve with the experimental data curve. In this section, is just giving information about the I'm sorry, I'm forget the. Okay, this is just a figure about dispersion curve and from the calculation from the VR.
Hello, Fajar. I think you lost your voice.
Oh, no, sir. Do you can you hear my voice?
Yes.
No, I don't know why, but I don't mute the microphone. I don't.
Yeah, please continue.
Okay. And in this figure, we can look the graphic from the self velocity of the in this figure, giving us information, but if Vs in 0 to 5, we can look Vs is to 100, and from the 5 to 15 is the cell wave velocity is 300. And in this
Fajar, we lost your voice again.
can you hear? Why?
Yes.
I don't know why.
You have 1 minute to conclude your presentation.
Okay, in this the end of this I can tell you, but but Indonesia, if the velocity lupa lagi kata-katanya. The greater of the deep, if the deep is greater, Vs will be great, and it is a give information if the Vs great, and it can meaning if the structure of the ground is hard. Okay. I think it's enough for me. Thank you.
Okay, thank you, Fajar, for giving us a presentation related to the railway wave application for detecting the surface wave in below our Earth, and we have time for 2 questions from the audience. Okay, on your last slide, you show us about the shear wave velocity.
Yes, sir.
How is it related to the surface wave? Yeah, because what I'm understand about the MISW method, we employ the surface wave velocity of the seismic wave that travels along the surface. So, but shear wave is another type of seismic wave that travels on the body of the Earth itself. And then, although it has the same behavior like the surface wave, but what I knew from MISW is that the profile that you can collect in the end is basically the surface wave velocity, not the shear wave. But in the last slide, you show us about the shear wave. So what is the connection between the shear wave and the surface wave?
Uh, uh, mm, so now sorry, I'm sorry. Maybe I can so here maybe I can for this time I can answer your question.
Okay. Thank you, Fajar, for giving us a presentation related to the MASW method. So for the sake of our time efficiency and effectiveness, we're going to move on to the second presenter, which is Pangeran Nitikusumo. Is Pangeran Nitikusumo in the classroom?
Yes, sir.
Okay.
Oops. Wait. Oh my. Can you see the slides, sir?
Yes. Okay, I just want to remember the audience that you have to fill in your assessment for each presenters. So while you uh, filling the assessment sheet, you may also need to sign up for the attendance list as usual on the SIX website. Okay, whenever you're ready, you may start your presentation.
All right. Thank you, sir. I will start now. Good morning, everyone. My name is Pangeran Nitikusumo. I am from the Department of Physics in the Institut Teknologi of Bandung, and my identity number is 10217 and 065. I'm here to present my research topic, which is the potential of lithium manganese phosphate as a cathode material for lithium-ion batteries with the use of doping. First, I will give some background. Rechargeable batteries are an electrical battery that can continuously charge and discharge a load, allowing for multiple uses. And a lithium-ion battery is such battery. Rechargeable batteries are very integral in our current life, having various applications such as listed before you, which are in use as portable electronics, electric vehicles, military equipment, and also in the Department of Aerospace Technologies. And then below that is an image of a structure of a lithium battery. In that image, during use, lithium ions will move from the anode to the cathode through the electrolytes in the process of discharge, while it will do so in reverse in the process of charging, and it will do so continuously until it runs out of energy. Next, here is a comparison between nickel cadmium batteries and lithium ion batteries, both of which are a type of rechargeable batteries. If you look at the comparisons, lithium ion batteries is more advantageous in every department except for the cost. But I will focus on two major points, which is its high energy density and its room for movement. Its high energy density is also applicable to be superior to most other rechargeable batteries, and it is believed to still be able to be improved, which is why I am doing this research. Next, how are we supposed to improve that energy density? It is by the use of doping. Doping is the process of adding impurities into a material to modulate its electrical, optical, and structural properties. What we are going to do with doping is to enhance the working potential of the cathode, which increases its energy density. The cathode material that I will choose to dope is lithium manganese phosphate, as previously said. And the method that is chosen to do this is by the density functional theory, which is a quantum modeling method which simulates properties of multi-body atoms. Next, there is more description on lithium manganese phosphate. Before you see a crystal cell structure of a lithium manganese phosphate. The green circles represent the lithium itself. The red represents the magnesium. Lithium manganese phosphate has an olefin structure with symmetry group PNMA, which also has a structure, a number structure of 62, and it has high insertion potential and high theoretical capacity, which is why I chose this compound instead of its currently more popular alternatives, which is lithium phosphate. The structure that you see presents channels along the B-axis, which is where it transports the lithium ions. When lithium ions and electrons are removed from lithium manganese phosphate, their remaining manganese phosphate framework maintains the same structure with a reduction of volume of about 5%. Next are the computational details that has to be used in order to do the calculations using the density functional theory. First of all, we use the generalized gradient approximation, or GGA, to calculate the total energies and properties of the atoms that we are using. We use the Perdue-Burke-Ernzernhof version, which is currently believed to be the most accurate at this time. Next, we take the data of ultrasoft pseudo-potential from the virtual library of the standard solid-state pseudo-potential library, which is available online. Next, we need to apply the Harvard University density functional theory, which is based as DFT plus U, to correct the electron correlation of localized d-electronic states. Why is this necessary? It is because that in d-electronic states, which is present, there is a very high column interaction, which is not currently accommodated by the GGA. And so we need to apply this theory to calculate it correctly. Next, lithium manganese phosphates can be ferromagnetic, paramagnetic, or antiferromagnetic. We are using the assumption that lithium manganese phosphate in this current experiment is ferromagnetic. First, because most applications of this lithium ion batteries is during room temperature, in which it is in the form of ferromagnetic, and also ferromagnetic and antiferromagnetic does not actually have that much difference in terms of its energy state. In my current research, I am not yet as far ahead to have completed my calculations. I am still in the process of modeling the atoms required. And as such, I will present you the information of what I will be completing, which is I will first need to calculate the lattice parameters of both lithium manganese phosphates and also the dope materials. No, I'm sorry, and also the version after it is doped. Next, I will also calculate the band gap for those two categories, and then I will also calculate the insertion voltage. Unlike all the others, the insertion voltage is actually has its own calculation formula, which is seen below, where all the others are simply calculated during the process of computation. And lastly, I will also be calculating the cell magnetization. Through these variables, I will then be able to determine whether this process of doping selection will prove to have a viable alternative in the, making lithium-ion batteries. That will be all for my presentation. Thank you very much.
Okay, thank you, Pangeran Nitikusumo, for giving us about the lithium manganese phosphate as a cathode material for lithium batteries. Although the actual work is not completely done, but at least there is some kind of a description or explanation about the modeling phase that you already done at this moment. So we're going to invite 3 questions for Pangeran Nitikusumo from the audience.
If there's no one else asking, I have a question for Eran.
Yes, go ahead.
Okay, thank you for the chance to ask. I want to ask about the technicalities. How do you compute those methods? Do you write your own code, or do you use a third-party program or something?
I write my own code, but the methods are already provided. How do I explain this? So in terms of the property, like lithium manganese phosphates, I need to insert like the properties of lithium manganese phosphate to model the atom itself. Here, I need to create this inside using density functional theory, but the process to do so is already provided using GGA and the likes. So yes, do you understand?
Oh, so you're just using a code, a GGA PBE code, and then you use it to generate that crystal model. Is that correct?
Yes.
Oh, all right. And then how do you check your results? Because you are making most of it you by yourself using some source code, but you also need a verification. So how do you verify your results?
Of course, simply by using a reference.
Mm-hmm.
I will simply compare my model with the reference.
All right. Okay. That's explained much. Thank you very much, Eda.
You're welcome. Thank you for the question.
Okay, another question from the audience. At what platform that you create the computer modeling?
Quantum Espresso.
In Quantum Espresso, the latest version?
I believe so.
Okay. And then in this model, what type of modification that you're going to apply later on after you got the actual measurement?
Oh, I don't understand the question.
Okay, so are you going to do some kind of a construction or measurement as well, or purely computational?
Purely computational, I believe. Because I will also be I will create the structure and then I will simulate an interaction, which is the interaction of doping, and then after that interaction is complete, I will have data which will then be my result.
And then the comparison is based on a paper or a reference book that you mentioned earlier?
Well, no, because no.
So what is the reference then?
Oh, the reference is for the model that I create. Like I will create a linear lithium manganese phosphate, and then I will also create the doping materials. Which, for example, I perhaps will one of the materials I will choose is nickel. So I will dope nickel into lithium manganese phosphate, and it will create lithium nickel phosphate, I believe, and during the yeah, so the reference is to make sure the before the doping that the materials itself are corrects to a reference.
And that reference is coming out from previous studies, or
yes.
Previous studies for research. Is it a computational research or a experimental research? The reference, I mean.
The reference is a computational research as well.
Oh, as well. Okay. Okay, we have time for one more question for Pangeran Kusumo. No more question? Okay, so therefore, I would like to thanks Pangeran Kusumo for his presentation, so that we can move on to our third presenter. I believe that Johnson Fernando Yangjo is already arrived in the classroom, isn't it?
Yes, sir. Actually, okay. I recently wake up.
Oh, okay.
I'm sorry.
So please prepare your presentation before we move on to your talk.
Thank you very much, sir.
Okay,
Yeah,
thank you.
welcome.
Now let me see. I think there's some. Okay, guys, can you see my screen now?
Yes. Can you make it full screen?
Yes.
Right.
Okay. I think what is another thing? Now, okay. Okay. Good. Uh, good morning, everyone. I'm sorry because I'm late. Hello, my name is Johnson. I'm from Physics of Earth and Complex System Research Group, and I will talk about the review the trans effect phenomenon from the King Crossfire underground fire. So our outline is actually it's we will talk about the introduction and then the trans effect phenomenon, and also we talk about the King's Crossfire. We talk about the computer simulation and experimental verification, and the correlation between the eyewitness and experimental research. And also we will from uh, that research, we will talk about the implication for eruptive wildfires, and also we talk about the implementation for public policy in fire safety. And after that, we will give discussion and conclusion. So let's move to the introduction. So actually, we know about the fire, right? Okay. So we know that fire is brings opportunity and threat for human beings. Why fire brings opportunity? Because our evolution is actually we can make the civilization is thanks to the invention of fire. So using a fire make our evolution to become more intelligent. But also we know they are a threat for human beings about the fire because fire can danger our life and also our properties. Uh, that's why we need to learn about the fire science. So fire science, especially fire physics, can make us more understand about the mechanism of fire and its behavior. By using this understanding, we can prevent the damage and loss of lives. Maybe the damage is actually can calculated as $100 million that from urban fire and wet fire disasters. So and then one of the fire disaster that happened in this world, actually this the I think it's the biggest fire in the underground. So it's called about the King's Cross underground fire disaster. So in November 1987, a small fire that ignited by discarded cigarettes on one escalator in King's Cross underground station spread quickly in just 10 minutes. It caused flashover that uh, burned into the ticket hall and also claimed 31 casualties life and a lot of injury. This one we will like to discuss it after this one. So, but before we know about this, we need to know about what is the trace effect phenomenon. So trace effect phenomenon is a phenomenon that can produce a developing fire prompt that accelerates up and create surface. The trace effect is actually influenced by two separate physical phenomena, the Coanda effect and flashover. So the Coanda effect is coming from the fluid dynamics and the flashover is coming from the fire dynamics. So Coanda effect will hit the combustible materials further up in the crane. So when fire is start, they will give in incline. The he will hit the gas that actually the gas is not rise, but actually heating up the another things in the floor. So actually it's climb up until when he reach the critical temperature, the fire will climb up rapidly, and fresh offer will be produced in matter of seconds. So actually, because the material is actually heated up, the fire will be go easily go up. This effect is become known because the scientific investigation of the King's Crossfire. So let's talk about the King's Crossfire scientific investigation. So in middle of December 1987, the Howell laboratory was executed by health and safety executive to stimulate the aerodynamics of the flow that may be leading up the flash offer. By using Howell Flow 3D software, they simulate the flows of hot gases through King's Cross station model in 3D with computational fluid dynamics technique. And also, they actually, from that simulation, it's actually calculated the hot gases. So actually, it's calculated the temperature uh, by its grid. So actually, they put the model with the grid. Uh, we can see the result in this picture. So actually, when scientists get this idea, they're making there's they're not believe that. I mean, like, uh, because it's the early result is very making any sense because it's defy our laws of physics. So many law of physics is defied. So maybe there was an human error, maybe, or first input, or maybe any bug in the program, maybe. But after they input again, they input the data again, recheck again, repeat again the simulation, the same result is shown by the simulation. So actually, they wonder what is it? So they conclude that the simulation showed the new phenomenon called the trans effect. That's like we already discussed in that uh, minutes in the before minutes. So actually, to prove this simul theory as the shown in the video, so they doing the some experiment. So it's actually coming from the layer one. So when the 7 minutes hour they were not like the soul split, but after that, you know, you say you see it, the flash over is begin. So actually, you can see what happened if you are uh in the top of that. You can see that you are in matter of seconds is you get the fire. So it's the fire is getting up to you. And actually, I want to say that actually this video is coming from the 1/3 scale model with the safe and ticket hard or complex. So by doing first in open channel, and then partly loop with channel in a 10 scale model and open channel, and after that doing that in the good way, we can see that the flash over is actually the test effect phenomenon is actually already verified by the experiment. And then, but of course, we need to know are the King Crossfire actually is actually uh, caused by this phenomenon. So you can see there are the eyewitness accounts. So actually, we can see in the 1940-30. So I'm sorry, 1940-40-30. So actually, when Mr. Bell, so Mr. Bell is the firefighters. So Mr. Bell, when he arrives at the bottom of escalator, so the frame is actually moved to the more than test effect is wanted to develop the test effect phenomenon. And then after that 45 seconds, when Mr. Bates, one of passengers, arrives in ticket hall, he is suddenly exposed by the flashover. So actually, we can see that the experimental result is show on it's only take 30 until 45 seconds to the frame from spread from the halfway height to the ticket hall once the test effect had developed. So actually, the experimental result is matched with the eyewitnesses accounts. And then what is the implication and implementation of test effect phenomenon? So for eruptive wildfires, so we can see this is the real photograph that taken by Mr. Stephen Wilkes in 2030 Canberra wildfires. So it showed that their extreme behavior, extreme fire behavior on slopes at approximately 30° and 40°. So it showed that there flash over in there. And actually the 30° and 40° is actually so actually the 30° is the minimum, is actually the critical angle for this phenomenon is established. So this behavior is matched with the test effect phenomenon. That's why we, after we know this, we can prevent the loss of fire factor lives from these eruptive wildfires, because actually in some wildfires there were a fire factor that trap it this uh, in this flashover. So actually by knowing this, we can like knowing how to prevent the loss of fire factor lives. And also for the implementation for public policy in fire safety, there was 157 recommendation from the Department of Transport after this investigation into the King's Cross underground fire. They talk about the evaluation of all escalators on the underground station across UK, the response of underground station staff and emergency service, and etc. So actually, after that disaster, they check all escalator on the underground station across UK, and actually, because they use like they use the wood escalator. So actually, in that era, they use wood escalator. The wood step is actually be replaced by steel, as we know the escalator today. Okay, and I think the implementation can be we can do more by evaluate all our stairs in public facility, and especially in our critical infrastructure like school, mall, hospital, and so on. I think we need also to more funding in fire science and safety research, and also we need to evaluate the forest wildfires mitigation planning, especially in that area that has slopes in 30 degrees above. Also, we need to evaluate our urban planning, especially the place our critical infrastructure and residential area need to know. So for discussion and conclusion, so the conclusion is King's Crossfire is caused by the test effect phenomenon through simulation and supported by many experiment and eyewitnesses account. Test effect phenomena have an implication for modeling wildfires in slopes area. Policyholders in fire safety should be more considered about test effect phenomenon in their policy, especially the policy for slopes area. And also, this is for discussion. So actually, the angles of slopes factor for the trans effect is already studied well and leads to conclusion. So we know about the angles of slopes, but we need do some research about the different geometry of slopes that affect this behavior of fire in this polynomial. I think it's thank you. Any questions?
Okay, thank you, Johnson. We have time for one question for Johnson.
Can I ask something, sir?
Yes.
Okay, Johnson, I want to ask you why you choose the king plus underground fire to know the trans effect. Thank you.
So, okay, I will answer. So what is the reason I choose the King's Cross underground fire for example of test effect phenomenon? So actually, as we know, this effect is actually we can know this effect thanks to the disaster. So actually, the disaster led the scientists to know and establish this theory. So because this is the origin of the trans effect phenomenon, so we need to run. If we need to run the trans effect phenomenon, we need to run it from the King's Cross underground fire, because the forensic investigation is actually so I would say the trans effect phenomenon theory is actually coming from the King's Cross underground fire investigation. Okay, I think it's all.
Yeah, thank you, Johnson.
Okay, thank you, Johnson. And who is the audience who asked Johnson?
Sandang, sir.
Okay, thank you, Sandang.
Thank you, sir.
So with that, I would like to thank Johnson for his presentation, and then moving on to the fourth presenter, which is Fajar Muhammad Ramdan.
Okay, sir.
Okay, I think I lost my. Where is it? Where is it? Oh, okay.
Stop screen.
Okay. I'm sorry.
Okay. I will share my screen, sir. Do you see my screen?
Yes.
Okay. Okay. Good morning, Mr. Harry and everybody.
Morning.
My name is Fajar Muhammad Ramdan from Physics of Earth and Complex System Research Division, Faculty of Mathematics and Natural Sciences, Institut Teknologi Bandung. Now I will tell about my paper, Geomechanical Test for Rock Characterization. Oh, okay, this is outline for my PPT. First introduction, then this data review, geomechanical test, result, more column failure criteria, and last difference. For introduction, I will explain about geomechanics and in situ stress. What is geomechanics? Geomechanics is one of the earth science that includes soil and rock mechanics, which was developed to find solution to problem related to subsurface contraction, landslide, and even problem that often occur in rock that become petroleum reservoir at very deep depth. Basically, geomechanics is the science of mining engineering and civil engineering we can apply to problem in oil exploration, such as the stability of wellbore. We can estimate how much pressure is given during the drilling process so that the wellbore does not break out. Because if a breakout occurs, then the losses incurred will be quite high. Okay, the sample to be tested from a large rock formation will be made into a small sample, which will be discussed in the next slide. Okay. What is in situ stress? In situ stress is natural stress in rock formation below the Earth's surface. The characteristic in situ stress is that has three principal stress. This is upper burden stress in vertical direction, and this is maximum horizontal stress, and this is minimum horizontal stress in horizontal direction. Overburden stress is the vertical stress component in rock formation below the Earth's surface. In the simple case, is caused by the overburden stress. Overburden stress can be calculated by integrating the density of rock layer below the Earth depth. Horizontal stress is caused by the presence of tectonic activity and geological deposition process. Horizontal stress can be divided into two based on the value of the stress, minimum and maximum horizontal stress. Okay, according to Anderson classification about stress condition in deep depth, there are three stress regime. First, normal fall, and this is biggest stress is vertical or overburden stress, and smallest stress is horizontal minimum stress, and then straight slip fall. Horizontal maximum stress is bigger than vertical overburden stress and bigger than horizontal minimum stress. And last, reverse fall. Biggest stress is horizontal maximum stress, and smallest stress is overburden stress. The principle of in situ stress is used to perform several rock mechanical tests in the laboratory. Mechanical tests are related to the strength of a rock or a rock response when under pressure. Okay. Now I will explain about literature review or basic theory about my study. Okay. Stress is a tensor that gives an idea of the density of the force acting on all surface at a certain point. There are assumptions for this study. Pressure is continuous, isotropic, and homogeneous. Okay, the stress component can be represented in the form of matrix. This is component matrix stress, and this is for equilibrium condition. Sigma 11, sigma 22, and sigma 33 is normal stress, and other is shear stress. Okay. Now I will explain about geomechanical test. Stage of testing the mechanical properties of rock in the laboratory. For first, pull core sample from field or wellbore. For example, the sample to be tested come from a wellbore, usually given from the company such as Pertamina, Sabersi, and etc. The rock sample are assumed to be homogeneous. Diameter 78.5 millimeter and length 0.9144 meter. Okay, next stage, making small sample to test. The International Society of Rock Mechanics provide recommendation for the size of the diameter and height of the cylindrical rock sample to be tested must be H per D is 2. Okay, from a large rock sample from a wellbore, an intake part is taken that represent the depth of rock formation. The sample were cut and made into cylinder with a diameter of 4 centimeter and a height 8 centimeter. The size of this rock is adjusted to the rock type and the rock availability. Okay, and next stage, rock sample that have been made of small cylinder or smooth and creamed. Usually, sample that have been performed before are still raw. Okay. For first test, I will explain about unconfined compressive strength. Unconfined compressive strength is compression test from the axial direction, which is used to determine the mechanical properties of rock, such as uniaxial compressive strength, Poisson ratio, Young modulus. In this test, cylindrical rock sample are pressed parallel to belonging to the axis. Just one stress applied in this test. This is a formula to calculate uniaxial compressive strength in experiment or measurement. Okay. The following is the stress strain curve of the uniaxial compressive test result. This is for y-axis is stress and x-axis is strain. This is elastic zone at rock, and this is point UCS, uniaxial compressive strength. Rock failure will occur in this point, in this uniaxial compressive strength. For next, I will explain about triaxial compressive strength. Triaxial compressive strength is a test of the mechanical properties of the rock, where the principal stress in the axial direction, sigma v, is applied along the axis of the cylindrical rock sample, and the other two stresses, sigma h, are applied in the lateral direction. In testing cylindrical rock sample, two lateral stress are applied in the form of tension in the rock curve surface using fluid pressure source. For sigma v is piston, form piston, and for sigma h from fluid pressure. Okay. This is one example of rock sample. This is sandstone, the result of the triaxial compressive strength. Okay. For next, I will explain about Baragilian test. Baragilian test is a method testing the tensile strength of rock. The Baragilian test is laboratory test conduct in rock mechanics indirectly determine the tensile strength of rock. The tensile strength of a rock is an important parameter in the wellbore stability. In this test, the sample size is different from uniaxial and triaxial compressive stress. Usually, the length of the sample is smaller than is the diameter. For example, diameter is 25 millimeter and length 20 millimeter. Jumikis state that the tensile strength of a rock is about 10% of its uniaxial compressive strength, and the ratio between the uniaxial compressive strength value and the tensile strength of a rock products a toughness ratio or stiffness index. Okay, this is for test result. This is a two rock type, limestone from Sakesar, Pakistan, and sandstone from Baghanwala, Pakistan. This is uniaxial compressive strength from limestone and sandstone, and this is for triaxial compressive strength. Sigma 1 is sigma v in axial direction, and sigma 3 is sigma h in lateral direction. And this is Baragilian test. Just information for the same rock type, from the location or rock formation is different. So there are some different characteristics. For example, limestone from Sakesar, Pakistan, with limestone from Cirebon or Parigi formation is different. Okay. Now I will explain about Moore column failure criteria. Moore column failure criteria is one of the rock failure criteria. The Moore column curve is formed with normal stress at the x-axis and shear stress at the y-axis. Basically, to make a more column curve, is it enough to only use uniaxial commutative strength data? But to get more accurate result, the triaxial and Brazilian test can be applied. The lines from on the curve show the boundaries at which a rock will fail. If the apply pressure exceeds the line limit, failure will occur. And if it's still below this line, will be no failure. This is a reference for my paper. That's all from me. Thank you. Any question?
Okay, any question for Fajar Muhammad Ramdan? We have time for 2 questions from the audience.
Yes, sir. I will.
Yeah, please.
Okay. Firstly, thank you very much for your explanation, Fajar. I
Okay.
have 3 questions. Is it okay, sir?
Yes.
Okay. The first question is for this test. Actually, we have to put some example, isn't it? So the example should be step by with cylinder. Can we make another step for this test? That is my first question. And the second question is, if we can see from your picture the mechanical test that more column failure criteria.
Yes. Yes.
You can see from the pictures there is some method that can be used: direct tensile, Brazilian, UCS, and triaxial.
Yes.
And from this picture, what is the efficient one, or maybe from the cost or efficiency? What is the best? What is the best efficient for this method? Okay, maybe that's all from me, sir. Thank you.
Okay. Thanks for your question, Alice. I will try to answer your question. For first, for application in geomechanic or characteristic of geomechanic, one of its application is the stability of wellbore or drilling process. Now, in the drilling process, it's if the mud white use is lower than the shear failure or stress or collapse stress, the shear and compressive damage that occurs in the wellbore with the direction of the minimum horizontal stress can cause a breakout. And if the mud white use exceed the tensile strength of the rock, there will be a tensile crack induced toward the maximum horizontal stress or fracking. For number 2, about efficiency data in more column failure criteria. To obtain an effective more column curve is usually sufficient to use uniaxial comparative strength data. Effective here is low cost and good result. However, if we want to get better or more accurate result, we need to do other tests such as the triaxial comparative strength, Brazilian test, tensile direct test, etc. And so for me, sir.
Okay, thank you, Alice. I guess in terms of the geomechanics, you need also to measure or estimates the pore pressure, because the thing that make geomechanical condition becomes closer to the failure is also the effect of volume of water that is inside of the samples. The abundance or the greater the volume of fluids inside of the samples, it will makes the failure become easy, and therefore it not just sigma 1, 2, and 3, which is important in terms of geomechanics, but pore pressure will also make contribution in terms of making the samples easy to fail. So probably if you Well, I guess that the condition of all samples that you have is in dry condition, I suggest.
Yes, in dry conditions.
Yeah, because you don't need to consider about the pore pressure. But if you have pore pressure, which is basically the real condition inside of the reservoir, where reservoir
Yeah.
contains water, oil, gas, etc., it means that if you can mimic the condition, okay, if you can make the condition as similar as the one that we have inside of the real reservoir,
Yes.
it means that we can predict the strength by calculating also or estimating also the significance of the pore pressure inside of the sample. And does the sample needs to be in cylinder form, or it can be in cubic or spherical?
Cylindrical form.
It has to be in cylinder.
Yes.
Okay, because the equipment. Okay, because the equipment and the device that we use for this test requires to have
Yes.
cylindrical core, right? But
Yes.
if we look at the samples in civil engineering, they
Yes.
have equipments that can detect uh, the failure using cubic size
Yeah.
samples, which is uh, it is appropriate for that application, but not with petroleum engineering application. So that's why we use the cylindrical shape, because even the well bore itself, okay, the shape of the well bore is in cylindrical, not cubic. But in civil engineering, they use another shape because they want to measure the sigma 1, 2, and 3 directly, okay,
Yes.
using triaxial stress, so that the sample becomes a cubic form. Okay, thank you, Fajar.
Thanks for your information, sir. Thank you.
Let us move on to the fifth presenter, which is Maria Arta Febrianti Turnip.
Okay, sir. I will share my screen.
Yes.
Okay, sir. First, is my voice clear enough, sir?
Yes.
Okay. I will start. Good morning, everyone. My name is Maria Arta Febrianti Turnip, and today is the great chance to me to present my paper entitled Superparamagnetic Iron Oxide Nanoparticles as Delivery Drug System. Okay, in the next 10 minutes, we will find out about first superparamagnetic iron oxide nanoparticles, second drug delivery system, and the last conclusion and the outlook. So let's start from this question: what is superparamagnetic iron oxide or SPION? To make the explanation simpler, we will focus to the name of the material and separate it into three parts. The first one, we will discuss about nanoparticles. If we take one strand of our hair and measure it with microscope, we will know that the size of human's hair is around 60,000 nanometers until 90,000 nanometers. We can imagine a nano-sized material by dividing it into 1,000 parts or 10,000 parts with equal size. We can see in this picture, the nano-sized material has size between the size of antibody 10 nanometers and virus 100 nanometers. With such a small size, a nanosize only can be observed under an advanced microscope. Next, we will discuss about iron oxide. So, as we know, pure iron metal exhibit greatest magnetic properties, which is ferromagnetic. But pure iron has poor stability if we put it in open space, or if the iron is exposed by oxygen or water in certain time. They will change into oxidation material, or we usually call it as corrosion phenomenon. Spions are used iron oxide nanoparticle that is produced in chemical experiment. So why we use the oxide form rather than the pure material? It is because iron oxide is easier to maintain rather than the pure form without losing the great magnetic properties. Next, the last, we will discuss about superparamagnetic. Superparamagnetic is one of form magnetism which arises in really small material which has magnetic properties between ferromagnetic or ferrimagnetic, or it can be appears from nanosite material. So why does iron oxide change in the nanoparticle form? Okay, firstly, we can start with knowing the ferromagnetic, which is the magnetic properties for iron oxide in the bulk form. As we can see in the first picture, ferromagnetic material contain with several domains with each magnetic moment orientation. It is called as multi-domain. Then, if the same material, if the ferromagnetic material is divided into a nano-sized material, sometimes material ends up having only one domain, or we can call it as single domain. Each particle has each orientation. This new feature is called as superparamagnetism. Okay, to know more about superparamagnetism, superparamagnetism is actually a paramagnetic material, but it has magnetization, saturation, or the maximum magnetization equal to ferromagnetic material for the same material. In this illustration, hopefully you will get the difference between ferromagnetic and superparamagnetic. First, the condition without any influence from external magnetic field. As we can see, for ferromagnetic nanoparticles, it has a multi-domain, and for superparamagnetic nanoparticles, it with its single domain with respective directions. Then we put the influence of magnetic field. We can see that the orientation for both nanoparticles change into the same direction to the magnetic field. But when we remove the magnetic field for the ferromagnetic nanoparticles, it will be the same condition, or it can maintain the magnetization condition. But for superparamagnetic nanoparticles, it will come back to the initial state. With this unique feature, we can switch off or on the nanoparticle with external magnetic field. Next, we can arrange the definition, our definition for superparamagnetic iron oxide. Spion is a functionalized iron oxide nanoparticles with a core size between 10 nanometers until 100 nanometers and an organic or inorganic coating, which exhibits superparamagnetic feature. In the left side, you can see 10 micrograms of magnetic nanoparticles. Iron oxide nanoparticles that can be used as the core are Fe2O3, or we can call it mahmite, and Fe3O4, or we can call it as magnetite. And these are the applications of Spion, especially for medical needs. For this time, we will more focus to targeted drug delivery, especially in vivo site in general. In vivo means we will inject the material into living organism body. After we synthesize the iron oxide, the second process is to confirm the condition of our material, which characterize it. A complete characterization of the particulate system is necessary to make a decision whether the use of nanoparticle system is appropriate for a specific in vivo application. The most important features are size of particles, toxicity, surface charge, and protein absorption capacity. These characteristics are controlled to prevent the aggregation or emboli within the capillary and to increase the safety for in vivo use. Next, we will discuss about drug delivery system. So, what is drug delivery system? Superparamagnetic iron oxide nanoparticles are used in drug delivery system by being attached to a drug and controlled by external magnetic field. If the drug has reached the targeted area, it will be released the drug delivery system by enzymes or physiological change in the body. For example, the temperature of the organ or pH. For example, we can see chemotherapy as the treatment for cancer. As we know, cancer is one of the deadliest diseases in the world and the most used treatment in chemotherapy. The one treatment that can be used is chemotherapy, and it is has many negative sides because chemotherapy not only kill the cancer cells, but it can kill the healthy cells. There are some kind of chemotherapy like chemotherapy infusions, chemotherapy pills, chemotherapy creams, and chemotherapy drugs, and so on. But chemotherapy will distribute in our body system, which affect to another part of human's body. They can damage healthy cells in the body around the cancer cell. Imagine if someone has breast cancer in the right breast and take chemotherapy pills. Before the pills arrive in the targeted site, it will affect the other areas. So, this is the new technology that can save our part of another part of body. So if we deliver the drugs into the right site, we can prevent the releasing the drugs in another part of our body. With Spion's unique magnetic properties, as we have learned, we can track the drugs with external magnetic field, like this. Once we switch off the external magnetic field, Spion stop at that area. Then, when we track it again into the cancer cells, the Spion will continue to find the cancer cells. And after find it, Spion will release the drugs into the right area. So we will not be worried again about the negative side of the drugs in the unwanted area. Next, for biomedical application of Spion, their surface are usually modified with various coatings and functional biological molecules to acquire the stability in solution, to increase the biocompatibility and decrease the toxicity of magnetic materials to the living organism. This process is called as surface modification. Surface modification can be carried out either during the synthesis or in post-synthesis process. Spion will be covered with suitable coating to improve the biocompatibility and circulation time in blood. We can see in the right picture, the magnetic core is covered with the lipid layer that contains a therapeutic layer or the drugs. And then after it, we cover it again with suitable coating to improve the biocompatibility. And the immune system in our body is not easily recognize Spion as foreign. So it will be not wash out from our body before it reach the target area. Its surface is further modified with various functional groups to detect and to bind to target molecules in the outer of the spine, like this. And the last conclusion and outlook. Superparamagnetic iron oxide are one of the easiest systems to produce. They have shown potential application in a wide variety of biomedical fields. Spines can be improved with surface modification process and act as a vehicle for the drugs into the target area. In the future, the study of injected material will improve the functionalized nanoparticles and its efficiency. If you want to know more about this material and its art of science, you can read this reference or feel free to ask me in the session. Thank you for your attention.
Okay, thank you, Maria, for the presentation. We would like to invite 2 questions for Maria.
Can I ask something,
Yes,
sir?
yes, please.
So my name is Sondang. I want to ask Maria. Maria tell about superparamagnetic iron oxide nanoparticle for medical need. I want to ask, can you tell me what are the advantage and disadvantage of the spine, especially in drug delivery system? Thank you.
Okay. Thank you, Sondang, for the questions. For the advantage, if we use superparamagnetic iron oxide nanoparticle, is of course we can reduce the dosage of the drug, as I mentioned before. For cancer drugs, it can be attack the healthy cells. So if we can track it, or we can deliver it to the right areas, we can reduce the negative side of the drugs in our body. And for the negative side of the superparamagnetic iron oxide nanoparticles, of course it is the toxicity, because superparamagnetic iron oxide is a magnetic nanoparticle. So the main study in this in recent time is about how to make the surface of the nanoparticle can be biocompatible and and no harm our body. I think that's all, Sondang. Thank you.
Thank you.
Okay, is there any quick question for Maria?
Yes, sir.
Okay, please.
I want to ask. So my name is Johnson. I want to ask. So is all of drugs can be used in this spine, or maybe there are some drugs that can use like can be included in that spion. Thank you.
Okay, thank you, Johnson. For in the reference that I have read, superparamagnetic iron oxide can be used for all drugs if we can if we can find the right the right capping material that cover the nanoparticles. So if we can find the the right surface modification, we can find we can make the spine for all the drugs. So it's the change for our future.
Okay, thank you.
Yes, thank you, Johnson.
Okay, thank you, Johnson and Maria, Johnson and Sondang, for giving Maria's question, and thank you, Maria, for answering the question from the audience. We would like to move on to the 6 presenters, which is Matthew Putro Amedio, talking about mechanistic modeling of the thermohydraulic in polydisperse flow film boiling in local condition.
I'm gonna start my share screen. Okay, can you see my PPT?
Yes, it is processing.
Okay.
Okay. Please make it full screen.
Okay, good morning, ladies and gentlemen, my friends,
Morning.
and Mr. Heri Mardika as our lecturer for this class. Today I'm gonna present to you my 15 minutes presentation about my specific paper review topic. First, I'm gonna introduce myself. My name is Meti Putra Madio, 102170787 from Physics Department, Nuclear and Biophysics Research Group. And my topic for today is mechanistic modeling of the thermal hydraulics in polydispersed flow film boiling in local conditions. Okay, let's start. This is the background. Loss of coolant accident or LOCA is a major problem during an accident or nuclear accident and yet to be solved effectively until now. And it is predicted that steam droplets have big impacts during heat transfer process. It's from Go and Mishima. I think they are Japanese nuclear scientists or engineers, I can remember correctly. And the last is an accurate way to determine the heat transfer is deeply needed. And as you can see at the right part of the PPT, you can see the image of two parts of clad rod that colored red. In the middle of it, you can see the droplet impacts and vapor or droplet transfers. It's just basically representing the prediction of Go and Mishima said that steam droplet have big impact during the heat transfer process. Okay. The Nectar coding stands for the new experimental code for thermal hydraulics analysis in a representative geometry. It is used to calculate heat and mass transfer as well as droplet dynamics in a nuclear system. And from what I've read from Pashay's paper about Nectar, it also can be used to perform simulation for the fuel assembly interchannel thermohydrodynamics interactions. And the main output from this coding is pretty much about the total heat dissipation by the internal two-phase flow by evaluating each heat transfer path and the thermohydraulics characteristics. And the result from Nectar is going to be compared by the Colibri, which short for the cooling of blockage region inside a PWR reactor. Stands for pressurized water reactor. It is probably one of the most common nuclear reactor in the world until today, I think. And it is used as the experimental rig or apparatus. Data taken from the Colibri is used as boundary conditions for the Nectar code as well as just to compare the Nectar codes and the Colibri results. Okay, this is the experimental apparatus. The part 1 and 3 from the picture, you can see that the first part and the third part are the fixed tubes. They are presenting a fluid subchannel in a PWR reactor. So basically just a tube for the flowing system. And part 1 is to provide the dispersed two-phase flow to the test section, which is to supply the droplets to the second part. And the second part is heated by the Joule effect from a power source. The second part is pretty much the observable area. And you can see that there is IR camera, LIF receiver, and PDA receiver. The infrared camera is used to measure the temperature profile of the external surface of part 2 during the heating or cooling process. And PDA, or the phase Doppler analyzer, is used to measure the axial velocity of the droplets. The last one, the LIF receiver, or the laser-induced fluorescence, is used to measure the droplets' mean temperature. And second part is powered by a DC power supply. And this is the experiment procedure. The first one, you just start the steam supply and let it flow for around 40 minutes to preheated the system. And then you start the droplet injection and power supply until part 2 reach 600 degrees Celsius. It actually doesn't have to be precisely 600, it can be around 500 to 800, just to simulate the local conditions, the superheated thing. And then you, once reach the steady state condition, we measure the diameter and velocity of the droplets as well as the mean droplets temperature. Well, the third part here is We basically use our infrared camera, a live receiver, and PDA receiver to take the data we needed. And the last is basically the cooling process. We just turn off the power supply to start the cooling process if we actually have done with our data collecting. Okay, this is the comparison with the actual local values. This table, you can see that droplets diameter, droplets axial velocity, and the volume fraction of droplets from the typical local values and the colibri, the upstream of the part 2, we can see that data is pretty much the same, or at least comparable to each other. But the steam temperature and the wall temperature is so much different. The typical local values is up to 800, while the colibri is only around 160 to 170, or probably 200, but it's still very much different because the local values is extremely superheated and so difficult to imitate or simulate, and it's too risky and it's dangerous for people who actually work with it. The same thing happened with the wall temperature. This is the simulation flow chart. Data from the colibri are wall temperature, the droplets characteristic upstream of part 2, and the injection parameters. And from this, we have two ways. The first one is data processing, and the second is the boundary conditions for the simulations. The data processing is just the heat dissipation by internal flow and droplets characteristic downstream, while the boundary conditions for the simulations used in the nectar codes, and the results are heat flux and the thermal hydraulics of each phase. And then both results is being compared between the experimental data and simulation. And here are the results. I'm just gonna tell you some of the results, not the entire results, because I took the most important part. This first one is validation with two-phase flow. Table 2 is the boundary conditions for the code. This is basically just the boundary conditions we use to input nectar codes. And this is the experimental results for the droplet dynamics. The left one is the droplet diameter distribution, and the right part is the axial droplet velocity as a function of the droplet diameters. And then this is the heat dissipation by the internal flow, the average values of heat transfer per unit length. As you can see in the picture, they are the term tracker. We're just gonna ignore the tracker term because it's basically just another coding. I only focus on the nectar and the experimental results. So as you can see that the lines are pretty much in harmony. The green one and the red and the blue one. So we can safely say that the experimental and nectar are pretty much the results are pretty much the same. And this for the droplets dynamics, diameter velocity correlation for each time period for the cooling phase. Well, the markers are the weird shape stuff are for the experimental results, and the lines are the nectar results for 3 blockage ratio. The A is 0%, B is 61%, and C are 90%. And we can safely say that it's pretty much like the previous result that the experimental and nectar results are pretty much similar to each other. So what we can conclude from the results? Well, we can say that nectar predicts with great accuracy, and especially regarding heat transfer and heat dissipation. And the nectar also predicts well regarding droplets dynamics, as we can say from diagram and the graphics. And the last one, droplets are indeed have big impact during heat transfer process, and hence we cannot neglect droplets during calculations regarding thermohydraulics calculations. And that's pretty much my presentation for today. Thank you.
Okay, thank you, Matthew. We have time for 2 questions. Okay, is your modeling also uh, able? So if we change the fluid in for the thermal hydraulic process, if we change the fluid with with some type of fluid, will it be available on the modeling?
I'm not really sure, but as far as I know, in this specific paper, we talk about only water. But I've read from Pak Shea, I think, paper, you can also use the liquid metal for the cooling system. So I just only knew either water or the liquid metal.
Okay. Okay. Any other question from the audience?
I want to ask a question.
Yes, please.
Is this nectar coding is the same as flow modeling?
Sorry, can you repeat the question?
Is this nectar coding is somewhat related to flow modeling?
I'm not really sure about that, but I can tell it is pretty much different, I think, but I'm not really sure about that.
Okay, thank you very much.
Okay, for the sake of efficiency of our presentation session, I would like to thank Matthew for giving us the presentation. And so we're going to move on to the last presenter of today, which is Kevin Mufid, talking about the measurements of material stress distribution using thermography methods.
Yes, sir. One moment, please. Test, test. Hello, is my voice already in here?
Yes, perfect.
Yes, yes.
Okay. Good morning, everyone. My name is Kevin Mufid. I'm from Department of Physics, Institut Teknologi Bandung, and today I'm going to present my topic, measurement of material stress distribution using thermography method. So, before we talk about the exact way we measure stress distribution, we need to talk why measuring stress distribution is important in the first place. So, the chart on the left shows the number of publications in material science over the year. We can see that the trend tends to increase, the number of publications increasing every year, and it's actually kind of an indication of how active the area of material science over the year. And it's actually very good because thanks to that, we could find numerous amount of innovation and invention in the area of synthetic material. And one of the synthetic material is actually Kevlar. So Kevlar, interestingly, is actually a synthetic material which was originally accidentally created. But despite that, this Kevlar is actually has a very good properties. So as you can see on the table at the right side, Kevlar has a really high specific strength. And it's actually bigger than natural materials such as spider silk and oak, and also even greater than titanium and copper, for example. And thanks to that high specific strength, Kevlar is actually now being used in rubber-proof tires and also in bulletproof vests. So Kevlar is pretty game-changing in those areas. And I think we realized that it's very, very important to measure new synthetic material properties, right? Because we need to know where we exactly could use our new synthetic material. So we need to perhaps measure the electrical conductance or measuring tensile strength or trying to measure its melting point. Anyway, we need to measure our new material, synthetic material properties depending on where we exactly are interested. And one of those properties is actually stress distribution. So stress distribution is basically how a material distributes its stress along its path when we give force to it. So you can see on the image at the right side, when we are trying to bend the beam downward, you could see that on the upper part, the color is kind of changing. That red part is an indication of a high stress on this area. And this image was actually generated using computer simulation because so far we are still unable to obtain a real material stress distribution. However, I'm going to propose a way to do this by using thermal distribution. And this is actually pretty important because measuring stress distribution could possibly leads to us measuring the uniformity of material, for example, from those stress distribution, right? And before that, however, we need to talk about the theory. So how exactly a material radiates its energy in the form of radiation. So blackbody radiation. So blackbody radiation is how exactly a material emits its energy in the form of radiation. And this radiation is not just a single frequency, but it is actually in the range of spectrum, as you can see on the image at the right side. And the spectrum has a peak that actually kind of changing depend on what the material temperature is, as you could see from the wind's displacement law. You could see that the lower the temperature, the higher the wavelength peak. And the higher the temperature, the lower the wavelength peak. So this is why at the room temperature, we are unable to see the blackbody radiation because it is in the range of infrared. However, at higher energy, at a temperature around 500 degrees Celsius, we might be able to see those blackbody radiation in the form of color, possibly in the red color because it is already in the range of visible color wavelength. So how do we exactly measure a material that is in the room temperature? So infrared category, we could use bolometer. A bolometer works kind of like an LDR, so like dependent resistor. So at like dependent resistor, the resistance of the material change depends on the light intensity. In the bolometer case, the material change its resistance depend on the absorbed heat. So the higher the temperature, the higher the resistance. And because of that, we also need additional circuit to measure the thermal temperature. We need to convert the temperature into voltage level if we need to measure it. And this is why we need circuits such as Wheatstone bridge or even amplifier to measure this. And there is actually an additional restriction that is bolometer generally requires you to cool down this material. So this material needs to be at around 0 degree Kelvin. So it's very, very limiting in its usage. Thankfully, in the recent advancement, there is actually what's called uncooled bolometer. So this uncooled bolometer could actually be used in the room temperature. So one example of that is material called vanadium oxide, and this vanadium oxide is actually already being used in the industry. So thermal camera manufacturer actually use vanadium oxide to manufacture their camera generally. And like I said, if we actually stack those bolometer into something that is like an array, we could try to capture a radiation that coming out from multiple different part of area. And as such, we could get thermal distribution if we are trying to use bolometer like a camera. So that's about it. However, we still haven't solved this yet. There is a problem that actually so far there is no paper that tried to do this. So I'm trying to find something that's quite similar. So what if someone used thermal distribution to measure a certain kind of mechanical properties, for example? And I managed to find this too. So Gallius managed to use thermal distribution in order to measure concrete structural defect. So depending on the level of the concrete defect, the material will have a different thermal distribution, as you can see on the chart and here. And Garnier also used thermal distribution in order to investigate the loading fatigue of composite material. So depending on the fatigue level, the material might have a different thermal distribution. So this is on the 0 cycle, and this is the very high cycle. So it's very, very different depending on the loading fatigue, right? And so I think it might be possible to do that. So in my case, I'm trying to measure stress distribution using thermal distribution. So the strategy is like this. I'm going to apply a mechanical force at the material, and the material energy will increase thanks to that mechanical force. And the energy next is being turned into heat. So it's like this. The image on the right is what's actually called friction welding. So by using friction, you could generate a very high temperature in those areas, and that's why the glass actually melts. So this is the detail of the setup. And so the material will be placed in the compression test machine, the machine that we use in experimental physics. And this machine then will compress the material. And after that, I will optionally heat up the material using a heat gun until a certain temperature. And after that, I'm going to measure its thermal distribution. And I will repeat this for different temperature and different load. So I'm also using two kinds of sample. The first one is just resin, and the second one is resin wood composite. So the resin wood composite is what's on the screen. So the wood part is on the center part, and the outer part is the resin. And I'm going to also use the test scenario, which is room temperature and also at high temperature, possibly around 100 degrees also. And that's about it. This is how far I have managed to get. And I'm still trying to synthesize the material, but I'm still having difficulties. And also another difficulties that I'm experiencing is that not much paper is kind of related to this. So I try to theorize something. So I need to learn more about the material physics, And also the IR camera resolution is very, very limited because there is actually an incentive of limiting the camera resolution of infrared because it is capable to be used at war. So that's why there is no high IR camera for public. So yeah, that's about it. Any question?
Okay. Do we have question for Kevin? We have
Yes,
time for
sir.
2 questions.
I have a question, sir.
Yes, please.
Okay. My name is Pangeran, and my question is, at the beginning, you said that finding out the stress distribution of a material is important, but also that there hasn't actually been a real method to figure it out. So why has there been no research on this previously? And like, is this actually as important as you say? Because it doesn't quite add up.
All right. So like I said, measuring stress distribution is kind of important, right? One example that I could say is that, let's say we just created a new material, but we need to know that whether or not the material that we created is actually uniform or not, right? So we could try to use stress distribution to do that. If the material have a uniform stress distribution, then we might be able to say that our material that we just created is actually uniform, which is good, right? So that's one example where we could use stress distribution. And the reason why stress distribution for real material is still not being able to be measured is because, yeah, it's pretty difficult to correlate the stress distribution with physical properties that we actually could measure. For example, to temperature or to other properties.
Oh, so it simply has not been attempted yet because of its difficulty.
Yes.
I see. Thank you for your answer.
Okay, is there any quick question from the audience before we finishing up our session today?
Want to ask a question, sir?
Yes, please.
I've read some papers about analyzing a machine failure, for example, or a pipe leakage. Is it also related to the stress distribution?
Sorry, paper about what?
I've read about like analyzing a pipe leakage, for example, using thermal
Pipe
camera
leakage.
or a machine failure. Yes, pipe leakage using thermal camera.
Yeah, I think it might be somewhat related. where that is on the real
Oh,
material,
yeah.
right? But I think we actually kind of need to discover a better way to do this, which is why I'm trying to do this, because I'm trying to look exactly for the stress distribution. Yeah. So that's about it.
Oh, yes, yes. Okay. Okay, thank you, thank you.
So I think this is my presentation. Thank you very much for listening.
Okay. Thank you, Kavit, and thank you for all presenters that have delivered their presentation today. We would like to thank all of the presenters, and then we're going to have another presentation session on next week on Thursday, April the 22nd. And so therefore, please send uh, your PPT into the folder that is already present in the LMS as the as a please send a copy just for the uh, documentation of the class, and then please for the next presenter should be relaxed and also have their practice done before the beginning of their uh, presentation time. Okay, thank you all. Let us meet again on next week. Thank you.
Sir,
Thank you, sir.
sir, I want to
Thank you,
ask.
sir.
So, it's okay. Is there a limitation for the PPT upload? Is there any like
What limit?
I think it's like the limit of like the I don't know. Mungkin pakai bahasa Indonesia aja.
Well, you can just copy and paste the thing that you already present today.
Ya maksudnya
Okay, so that
PPT-nya ukurannya boleh besar. Seberapa besar, Pak?
oh, it's
PPT.
okay. It's okay.
Oh, okay.
Or if you think that the size of your PPT is too large, you can change it into PDF.
Okay, thank you. So.
You're welcome.